Alright, here we go. This video is being recorded in front of a live studio audience. Hopefully they'll cooperate and be quiet for me. This video is on the Pythagorean Theorem, which is going to apply to the Pythagorean Identity and coordinate trig. Do not be confused with coordinate trig and unit circle trig because they are different. So what we're going to do is we're going to use the Pythagorean Theorem to find sine, cosine, and tangent of a given coordinate. So what you need to do is sketch a little graph of what that coordinate looks like. So you have your unit circle here. And the point 6, 8 obviously is going to be in quadrant 1, 6 to the right and 8 up. So here is our 6, 8. So you need to draw a triangle with those coordinates. So here we go. We always use our reference angle to the x-axis. So we know that this is our 6, this is our 8. So what is our hypotenuse going to be? Well, that's just going to be 6 squared plus 8 squared is equal to c squared, and I'm sure you can figure out by that 100 is equal to c squared, so c is equal to 10. So your hypotenuse in this situation is 10. From here, all you have to do is use old school SOHCAHTOA with your reference angle, of course, right there by the origin along the x-axis. So sine is opposite over hypotenuse, so you have 8 over 10. Cosine is adjacent over hypotenuse, that's 6 over 10. And tangent is opposite over adjacent, which is 8 over 6. But you would never leave them like that because you know you always reduce your fractions. So the final answer for the sine of theta is 4/5. Cosine of theta is 3/5. And the tangent of theta is 4/3. Now you always want to leave these in exact answers. I do not want any decimals. Since you're using the Pythagorean theorem, there is a chance that a radical will come into play, but that'll be up to you to take care of. Okay? So here's an example for you to try. Pause the video, give it a try. Alright, check your work. You had to use the Pythagorean theorem and you get c squared is equal to 52. So of course I said you have to have exact answers. So the square root of 52 will simplify to 2 root 13. So your hypotenuse is 2 root 13. So sine is 6 over 2 root 13, which would simplify to 3 root 13 over 13. Cosine is going to be negative 2 root 13 over 13. And tangent would be negative 3 over 2. So that's how you use the Pythagorean theorem with coordinate trig. Now we're going to take Pythagorean theorem even further and use the Pythagorean identity in trigonometry. It's very similar. The process is the same. It's just now you're going to be working with sine squared plus cosine squared is equal to 1. That is the Pythagorean identity. Now, when the directions say to find all possible values for cosine and sine, rounded to the nearest 10,000th, you're going to have two answers and you're going to have two different quadrants. So to start this problem, what you want to do is, again, draw your cosine value. Now think about cosine. It says that it has a positive 0.5437 value. Well, where is cosine positive? It's positive in quadrant 1 and in quadrant 4 because cosine is your x value. So from here, you're going to set up your Pythagorean identity. So you're going to have your sine squared theta plus 0.5437 squared is equal to 1. So you're going to have to use your calculator. Now your calculator is going to give you some big, long, nasty decimals. So I recommend waiting till the very last opportunity to round to the nearest 10,000th. So in your calculator, you're going to type this in and you're going to get sine squared theta plus 0.29 yada, yada, yada is equal to 1. You're going to subtract that 0.29 something by doing 1 minus the answer, and you'll get sine squared theta is equal to 0.704 yada, 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 yada. So from here, all you have to do is take the square root of that. Now you can do that one of two ways. You can just do the square root of second answer and then find that, or you can just raise this to the 0.5. Remember, 1/2 powers are the same as square roots. Either way you do it, you're going to get that sine of theta is equal to 0.8393. But from here it said you have to find all values and you have to state which quadrant. So since cosine was positive in quadrant 1 and 4, you have to say that sine of theta is equal to a positive 0.8393 in quadrant 1 And you also have to say that sine of theta is equal to a negative 0.8393 in quadrant 4. Because if you think about it, sine is positive in quadrant 1 and it's negative in quadrant 4. So the original problem determines which quadrants you're going to be in. The Pythagorean identity will tell you the answer for both those quadrants. Okay? So I did an example for you. You get to try example number 2, and then we'll try it with sine. Give it a try. First thing you had to do is set up that the cosine is negative, so that's going to be in quadrant 2 and 3 because that's where cosine, your x value, is negative. Set up your Pythagorean identity. Use your calculator to solve all these crazy decimals, and then you're going to get 0.9397. So it's positive, sine is positive in quadrant 2, but sine is negative in quadrant 3. And that's it, you're done. So we have another example to try, and this is when you're given sine. And then you'll have one more to try on your own, and then we'll be done for this video. So the sine of theta, when sine is positive, you have to remember sine is y. So sine is positive in quadrants 1 and 2. But the work is still the exact same. So all you're going to have to do is set up your Pythagorean identity. That's going to give you 0.4828 squared plus cosine squared theta is equal to 1. Use your calculator to do all the fancy stuff, and you're going to find out that the cosine of theta is equal to 0.8757. Now, since that's positive, when is cosine positive? It's in quadrant 1. So then you just have to also remember to say that it's equal to a negative 0.8757, but that's going to be in quadrant 2 because that's when x is negative. So the last example is yours to try. See if you can handle the sine of theta is equal to a negative 0.1721. Give it a try. So in this one, sine was negative from the get-go, so you had to start sine in quadrant 3 and 4. Use the Pythagorean identity to find out that the cosine of theta is equal to 0.985. So it's positive in quadrant 4 because that's where x is positive, and x is negative in quadrant 3. And that's it. You are now completed with the Pythagorean identity and coordinate trig. You have a quiz coming up tomorrow, so we'll see you. Bye. This is Longo, and I'm out. See you. Bye.